Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Today we are going to look at a concept in definite integrals, and this is basically one of the definite integrals as we had mentioned earlier in our introduction to definite integrals. So in this specific case we are going to see that one of the application areas as we had mentioned is finding areas under a curve. And we're going to use an illustration on the board that is going to assist us, of course, evaluate this specific area under the curve for a function of y is equivalent to x squared given as such. So in this specific case, I'm going to have my upper and lower limits of integration given as 0 and 4. So that is our main area of interest for this specific case that I'm going to indicate using A. So in this case, I'm going to apply the concept of from our earlier discussion on the that specific concept of the theorem of the fundamental theorem of calculus that we had mentioned. Now, earlier on, we had said that we can be able to give the general formula for this definite integral for a function of fx dx given as f b upper limit minus f a given a lower limit as such, whereby we had said that this particular function is going to be integrable over this closed interval a and b, and we're going to also see that this specific function for finding the areas is going to be applicable for a function that is greater than or equivalent to 0 given as such. So therefore we're going to allocate our upper limit for upper limit of integration as b and lower as a generally in that specific case. But for this one, we are going to use this specific function that we have been given, whereby our lower boundary has been given as 0 and the upper boundary given as 4 given as such. So therefore, in us trying to evaluate this, we are going to give this area of this specific integral as the integral from 0 to 4 of our function, which is our x squared dx. Then therefore, this is going to be given as, or rather you can just use this space. So this is going to be given as x cubed over 3 from the limits of 0 to 4 given as such. So this is going to be evaluated. So I'm going to use these specific points. So the cube of 3, the cube of 4 for that specific point can be given as 64. So as we can realize, for the lower limit, that's going to be have of course the substitution for x is going to give us 0. So basically we're just going to retain or rather remain with the value of f b for the upper limit only. So therefore this is going to give us 64 over 3, which is 21 and a third. And this for the area we can be given in different units, and basically this is going to appear in terms of a square unit. So that's going to give us around 21 and a third square units